Hi, this is going to be a demo of how it can be advantageous to deviate from typical React patterns of function passing and component local state and use something that is event bus oriented called the RxFx service. And it can lead to really some improvements in applications, particularly as they scale or different parts of the applications are contributed to by different teams. So in other words, this is a thing that will work very well for a federated model or a large team. Now, it's powered by RxFx bus and service, which you can take a look at here on GitHub, but I'll be showing you specifically all the things that it can do. So why bother? There's a few things that happen in larger React applications. Errors from one part of the app can break other parts of the app. You can manage this with React-specific features, or you can manage them in vanilla JavaScript. We'll show you how to use vanilla JavaScript to even create smaller domains of errors, kind of like fuses in a fuse box or circuit breakers. We'll see that this pattern reduces the need to prop drill. In other words, passing functions and state setters down from parents to children, which we've seen doesn't scale very well. And that very pattern can lead to memoization or stale data issues as functions are passed and not properly memoized. We'll also see that this pattern can lead to files that are single-focused, unlike this app right now, which does, I think, at least 3 things. We're going to split it apart and have single-focused files. And that'll this event bus pattern allows for dynamic enhancement as, say, modules are loaded and unloaded from your app. And that dynamic enhancement can allow components to stay done once written because they can be enhanced from the outside, etc. A lot of benefits, testable outside of React, so faster and usable even in an Angular context because we're abstracting concepts out of the React zone. So that's what we're going to do. Our strategy is to take this counter app and split it apart in better ways. So what do I mean by better ways? Well, let's take a look at the default error behavior of React. Then we are fine up to a point. We even get one more click because of React closure issues. But then our next click, our entire UI has died. And this is kind of a symptom, I think, of our application just doing too much. So we're going to split this up. So the first step will be to extract this button component. I'll do that silently. Okay, this is our first stopover. We extracted the button and we still needed to pass the function prop to set count and the count itself, and things still work. This is a good first step. But we're going to look at this counter button and ask, is this as simple as it can be? If not, can we extract some things to the React free zone? And I believe we can. I believe this here is actually a kind of reducer. So that's where I'm going to start, is extract this reducer to the React free zone. And this is our second stopping over. Once again, we are still working. However, we have a reducer that is very unit testable outside of React. Now, let's address these props. It would be really nice if the counter button's only job was to say, hey, I want the count to go up by 1. So our goal is going to be now that on our click handler, we don't take a set count from the parent anymore, but we have some sort of object called a counter service that's going to keep track of the state and allow us to make requests of it. Doesn't exist yet. It will. And that will make our component single purpose. It receives counts to display. It calls request and passes an increment, and it'll never have to change. We'll finish this outside of out in the vanilla JavaScript land. So here's our counter reducer. It isn't a flux standard action reducer, but we can actually get away with it being this simple for now. If we initialize it to 0, that would be a good idea. Now we're going to call the counter service that, remember we wanted to be able to say counter service.request1, okay? So we're going to define this, and we're going to define some types for it in just a second. I'm just going to say that the requests you make of it are numbers. It doesn't return anything from its effect. We'll see how services can manage effects in another demo. It doesn't have any special error property. The default error will be fine. And the state that it manages is going to be the number. So those are the types that it's going to take. The arguments it's going to take are a namespace, we'll call it counter, a bus, an effect, and a function that returns a reducer. So we're going to call the create service method. We'll give its namespace counter, bus. There is no bus yet. We'll get to that in a second. And then this is a null effect. It doesn't run any async functionality, but it could. We'll get to that in another version too. And then we'll return the counter reducer. Now, how do we give the service a bus, and why does it need it? Services that are connected by the bus can be globally shut down, restarted, etc. So we'll get into that in another demo. But for now, let's just pull the default bus from RxFx bus and name it bus, and our component should be our counter service should be complete. Let's export it. And what will we get here? Well, nothing yet, because we have moved the reducer running to this component, but app is still thinking it's using component local state. So we have no behavior there. Const state count comes from use service counter service, and now our state actually is updating. However, it's updating by too much, and that is just because our naive reducer that we used doesn't take into account which action we got and whether its type is counter service request. So we have limited our reducer to only run on counter request actions. And now our app, by way of use service, can use that service's ever-changing state as its local state. And we can make things just a little more type safe by putting in our types for create service. Again, they are number, void, error, and number, corresponding to request, response, error, and state. And this just gets us a little bit more tight. Also, we don't have to use the string counter request. And by doing that, it knows that the payload is typed to be a number. So we've got more type safety this way. And let's see how that works. We got it. Okay. With this level of functionality, we have handled a number of things. Our errors can't break unrelated features. We didn't have to prop drill. And our components can stay single focused and done. But now let's talk about how you might enhance this behavior without changing the counter button. So suppose that we have a period of time in which increments are actually going to be doubled. We don't want to have to go back into counter button and change this value because we don't have to. What we can do is go to the app and imagine that we had a component called a doubler. And as long as this component is in the tree, things get doubled. How would we write such a doubler component? Well, we're going to take advantage of some of this event bus magic, and we already have an import for the bus, and we have a hook called use while mounted that we'll need in just a second because it's a doubler. Now, this looks like it should be correct, but if you know anything about React strict mode, let's start this again. If you know anything about React strict mode, you'll know that it double runs your effects. And there's something we're not doing here, which is actually turning this filter off. Now, we could do this by capturing the filter in a variable and returning filter.unsubscribe from the function. That'll work, and now we'll have single doublings. This will only be filtering once. But I'd actually like to make this a little bit shorter and just use a hook that is custom built for this purpose called use while mounted. And from here you can just return the filter itself, and the doubler will only do the doubling once, and now we don't need React use effect. So it's so neat that without the doubler, count goes up by 1. With the doubler, so this is just the tip of the iceberg. It has better error isolation, better component decoupling. You can enhance things on the fly without either the counter button or the counter service needing to change on account of it. And I think this is a good baseline for a federated architecture where services are what your application is largely composed of, and then you just slurp their states back into React, but you don't use React primitives to actually build your state containers or run your effects. This can do a lot with effect running. We haven't gotten into that, but if you wanted to have a delayed counter, there are demos on that. And once you have delays, you actually have to get down to concurrency, the kind of stuff that RxJS manages really well, where your delayed effects can run in various modes. But then again, that's going to be for another demo. I think architecturally, this pattern will improve React development and frankly just make it less error prone and more fun. Hope you enjoyed it.